Good morning. I had a couple of students ask if I could make some additional examples. So I'm going to do a couple of the problems from the study guide intervention page 31. Just some more examples of factoring by grouping. So 13, 16, and 17 are the problems that I'm going to do. We need to start each of these using the same method. We've got to break it up into two groups. So we'll do two groups, and then we'll find the greatest common factor for each group and turn it into a multiplication of a monomial by a binomial. So here we're going to look at x squared and 2x and find the GCF. And over here we're going to look at x and 2 and find the GCF. And then we'll turn it into a monomial times a binomial plus the monomial times a binomial. That's what you should do every time. Then you can turn that into a multiplication of two binomials. All of them look like that. So we have to break down x squared, that's x times x. 2x is just 2x. Then you find what do they have in common, greatest common factor. In this case, it's only that x. So we'll have x as the GCF. That is the monomial that goes outside of the parentheses. And then we write what's left. We had x squared plus 2x. So then we're going to have what's left in the first term, x plus 2. Okay, we look over here. X is only x, 2 is only 2. So they don't have anything in common. We can't leave it blank because we have to put something in this term. This isn't just going to be x. It has to be x plus something. So what you can think about is I can write x as 1 times x. And I can write 2 as 1 times 2. So these have a common factor of 1. Whoops, excuse me. Common factor of 1. So that's going to be a 1 right there. And then what do they have left? X for the first term, plus was my sign, and 2 goes there. So now the goal was that these would match, and they do. So this second term is the matching term, x plus 2. The first term is the outside monomials. So we get x from the first one and 1 from the second. So your answer is x plus 1, x plus 2. That's the process we're going to follow every time. That one was a basic one. 16, they're a little more complex. So we're going to write down 12ax and 3xz. That'll be my first group. My second group will be right there. And I'm going to find the greatest common factor. I'm going to then write them as monomials times binomials, and then the two binomials times each other. Okay, our second groups are 4ay and yz, and we have to find the greatest common factor with those as well. Alright, so 12, if you need to make a factor tree, go ahead and do that. 12 is 4 times 3, and 4 is 2 times 2. So 12 is 2 times 2 times 3, ax. 3xz will be 3x and z. Those are all prime. So what can we pair up? We have a 3 and we have an x. Everything else is unique. So my greatest common factor is 3x, and that goes outside of the terms, outside the parentheses. And then what's left on the inside? The first term has 2 times 2, which is 4, and what variables? Just an a. The second term, 3xz, we took the 3 and the x, we just have the z left over. Okay, let's look at the next one, 4ay. So 4 is 2 times 2. Then we'll have an a and a y. yz, those are both just primes, so we've got yz. What do they have in common? This y. So my greatest common factor here is only y. And then what's left? So we have 2 times 2 times a, or 4a, and then z for my second term. We took the y, we left the z. So our goal was these two things match. That is my second binomial. I can just fill that in, and it's only one time. My other binomial is what's left. So 3x is out front here, y is out front here, and we always use a plus. If you're going to end up with a minus, it's going to happen because they had a common factor of a -1. So this is the final answer there. Last one, 17. So we've got to pair things out. We'll do grouping there and grouping here. So 12a squared and 3a, we're going to find the greatest common factor. Negative 8a and -2, we're going to find the greatest common factor. And again, we're going to end up with a monomial times a binomial plus a monomial times a binomial, and we're going to end up with 2 binomials. So we've got to factor things out. We did 12 already. Up here, it was 2 times 2 times 3. So let's just use that again. 2 times 2 times 3, a and a. Put my divider there. Okay, bring this back in the middle. 3a is just going to be 3a. So we have to circle what has in common. We've got a 3 and we've got an a. Okay. Hopefully you see now, I've said this many times so far in my videos, we've taken both pieces out of this. So if you need to remember to put in a 1 there, put in the placeholder of 1. Okay, what do they have in common? 3 and a, so that goes out front, 3a. What is remaining? 2 times 2 times a, so 4a, plus, and you have to write down this plus sign for the second term, so if that isn't enough, you look here and say, we reminded ourselves with this 1, it's 4a plus 1. Because there was nothing left in the 3a, but it's a factor of 1, not a blank and not a 0. All right, negative 8a will be negative 1 times 8 is 4 times 2. So 2 is prime. 4 is 2 times 2. So we have 3 2's. 1, 2, 3, and 1 variable a. Negative 2 is just negative 1 times 2. So our common factors here are -1 and 2. And once again, I took everything out of here, so I'm going to write times 1 to make sure that I have a placeholder there. Okay, so our greatest common factor is -1 times 2, or -2. So I'm going to put that in parentheses to remind ourselves that it was a -2. And then what's left? 2 times 2 is 4a, and plus, because we already took the negative away, 1. Okay, so we have our matching binomial. We can write 4a plus 1 as the matching binomial. And the leading coefficient one is 3a, what's on the outside, plus a -2, so ideally we're just going to write -2. Alright, so hopefully those examples help us as a good review, or some additional examples to help get on track with factoring by grouping. The next step in these sections are to take each of these factors and set them equal to 0 and solve. But if you need some more examples on those, we can do that. Keep letting me know if you have any questions, and we'll keep moving forward.